Welcome to our first session in corporate finance. We'll be discussing time value of money. Time value of money is a focal topic in corporate finance upon which all other topics hinge. And so in this class, we'll talk about aspects of interest rates, how to calculate the compound interest, future interest, and how to go to annuities. So to start with, simple interest is simply the interest that is not reinvested. Simple interest is simply the interest that is not reinvested. And so compound interest is interest that is earned on interest invested over time. When you're discussing future value, we're looking at the amount of an investment worth in the future at a given interest rate. So for you to understand these two topics, I'll take you to annuities. So you have 100 kwacha now at a rate of 10%. So 10% of 100 kwacha gives you a value of 10 kwacha. So this value of 10 kwacha will be consistent. When the value is consistent, we're going to have 110 in year 1, 120 in year 2, 130 in year 3. So when the amount of interest is consistent based on what we call the initial value, this is called simple interest. Now, if the percentage is based on the previous amount, so if we're starting with 100 kwacha and we're using 10%, 10% of 100 kwacha takes us to 110 because 10% of 100 kwacha is 10 kwacha. When we do 10% of the amount in year 1, this amount that we are having here is 110. So 10% of 110 is 11 kwacha. So this is the 11 kwacha that we are going to add to the 110 to give us 121. Then the 10% will now be based on the 121. 10% of 121 will give us 12 kwacha, 10 ingwe. So when you add the 12 kwacha 10 ingwe to this amount, what you're going to have is 133.10. Now, this is the analog way of calculating the future values, but you're understanding the fact that what you're using here is an arithmetic progression, and what we're using here is what we call a geometric progression, a GP. Now, each of these ones have a formula that you use to calculate, because you may not have all the time to calculate the annuities, to calculate the future values, to calculate the progressions manually. So I know most of you already know this. I'm going to start from what you already know to what you don't know. So to calculate simple interest, we calculate it by using the formula PTR. And the examiner will tell you that this is simple interest. For the compound interest, we calculate the compound interest by subtracting the future value minus the future value minus the present value. Now, the future value is what I'm so much interested in. This one is given by present value 1 plus R to the power time. Now, this is time given in years and the rate given as a percentage. So the future value formula is later on generated as follows. This is future value 1 plus R over M, where M stands for the number of times you're compounding. Now, to compound is simply to add interest. The compoundings are done in the following ways. When you're compounding, you can compound annually, you can compound semi-annually, you can compound quarterly, but these terms are the basic terms that you will be using time and again. Annually means you're adding interest once. Semi-annually means we're adding interest twice. Quarterly means we're adding interest 4 times in a year. If we say monthly, we're adding interest 12 times in a year. If we're saying weekly, we're adding 52 times in a year. If we're adding daily, we are talking about 365 unless otherwise mentioned. Now, the issue of compounding is very important because it affects the rate by dividing the number of compoundings and multiplying the time by the number of times you're compounding. Now, this basic information is very important because it exposes you to understanding the concepts behind. Now, when you're dealing with future value and present value, please, I need you to take note of these basic steps I'm giving you. So using these formulas, I will take you through some questions that we're going to look at, but let me go through the basic. I've compiled a number of questions from 2017 upwards. I would want us to apply whatever I'll be discussing onto these questions, but without underrating the fact that others are starting from scratch. Let me suppose you're given an amount. You start with an amount. Any amount that you start, we use P0. That is called our present value or our initial amount. We start with an amount of 1,000 kwacha. And our interest rate is 8%. And we are told the time is 5 years. So we're asked part A to calculate the simple interest. Okay, can somebody try? How do you find the simple interest here? What's the formula for simple interest? Our simple interest is PTR. So we have our amount we started with as 1,000. Our time is 5 years. So time is always in years. If we're given 5 months, we'd have written 5 divided by 12 because we have 12 months in a year. If we're given 5 weeks, we'd have divided that 5 divided by our number of weeks, which are 52, and times the interest rate, which is 0.08. What are we getting? What are we getting there?
400.
So 400 is what we call our simple interest. 400 is our simple interest. Part B, if you're asked to find the compound interest after 5 years, firstly, we need to calculate the future value. Now, I'm going to modernize this question. If you're asked to calculate the compound interest compounded annually, B compounded semi-annually, C compounded quarterly. So firstly, we need to find our future value. Our future value can be calculated manually or using the table. I usually prefer students to understand the manual way because with or without the table, you're able to understand this. So the formula for annually is 1 plus r to the power t. Now, if we're discussing the future value, we're looking at the amount yet to be gotten in future. So our present value, how much are we starting with? 1,000 kwacha. Then 1 plus r, our r is what? 8%. So 1.08 to the power time. Our time is 5 years. So put our 5 there. What are we getting? What are we getting? We'll do well every time we have class, have a calculator nearby and write what we are doing so that we move fast.
We're getting 1,469.33.
Okay. 1,439.69.
69.33.
0.33. So one thing you need to notice is that the more you compound, the higher the figure, because to compound is to add interest. Now, each time you're compounding more than once, always use this formula. In fact, this formula is even safer because you'll not forget to recalculate the interest rate and the period of time. Now, the reason why we multiply the number of compoundings times the time is owing to the fact that if you are compounding semi-annually, so meaning you're either earning interest twice a year, all right? Semi-annually means twice. So you're going to multiply, if it's times 1 year, so 2 times 1 year, meaning you're going to earn interest twice. Now, if you are compounding quarterly and it's 2 years, so meaning every year you'll be getting interest 4 times, times 2 meaning 8 times. So the 8 doesn't mean it's a number of years, it's a number of times you'll be earning interest. So here, semi-annually means how many times? Can somebody remind me?
Twice a year.
Twice a year, excellent. So now, as I repeat, this seems to be an introductory class, but very important, as I'll be discussing bond valuation tomorrow because it will be based on this. All right? So this will affect our interest rate. R will be divided by the 0.08 will be divided by what? By M. M in this case is 2. Then this 2 multiply times the time. 2 times 5. What do we get? So we're going to have 1,000 here. Then here, 1.04 to the power what? 10. So what are we getting? What are we getting as a final answer?
1,480.244.
80.244. Okay. So ideally here, you see the more you compound, the higher the figure goes. So quarterly here, without explaining the answer here, what we're going to put here is a what? Is a 4. Then the 4 will be multiplied by the 5. So here we're going to have 1.02. Then this will be to the power 20. And the figure will be bigger. So what we are learning from here is simply the fact that the more you compound, the higher the figure you get. Now, besides this, whenever you want to compare figures, there's what we call the effective annual rate.
Sorry, sir. I've got a question.
Uh-huh.
Is it possible to go back where we're coming from? Yes. On A, okay, on this previous question, what are we supposed to get? Are we just getting the interest figure only or what?
Yes, the question is asking for the interest. So on A, after
So
finding
for
the future value, you're going to subtract
mm,
1000 minus the 1400. So the interest itself is
also the
451.
answer is just the difference.
Yes, the difference, yeah. Same with part B, we're
Okay.
subtracting from the 1000 kwacha to get the difference. Okay.
Okay. Thanks.
So what we're learning is how to apply the future value aspect. Future value is very important because it helps us ascertain that the value of a dollar today is different to the value of a dollar tomorrow because of the issues of interest rates. So the other things that you're going to get are simply manipulations of formulas. For instance, from what I've told you now, suppose you're given a future value, which is what 10,000. Given a future value of 10,000, and you're given the interest rate of 10%, and we are asked that this is compounded quarterly for a period of 6 years. They'll ask you to find present value. So I'll be very frank with you. This topic is easy. You just need to understand also how to do something with the formula. It will come to say Mutale wants to save an amount now to raise a school fees of 10,000 at an interest of 10%, compounded quarterly for 6 years. How much must she invest now? So I've already given you the general formula that you need to know anywhere. That future value is equal to present value 1 plus R over M, everything divided by everything to the power MT. So let's do this together. What have we been given? The future value of how much?
10,000.
1,000.
The present value.
According to Wikipedia, 1,000.
What else are we given? The interest
The rate 10%, which is 0.1.
What else?
Over
Over 4. Why over 4?
Is that 4? It's over 6. What number is it?
Quarterly.
Quarterly.
Oh, okay.
And the time is what?
6.
6 years.
All right. So here we're going to have 10,000. And here present value. Then here we're going to have 1.125 to the power what? 24.
24.
So you calculate this part here. So meaning our present value would be 10,000 over, what figure did you get? 1.125 to the power 24.
Mr. Collins, I have a question.
Yes, sir, madam.
1.10 divided by 4 is 0.275.
What is this 0.1? 0.10 divided by 4. What do you get? You're only dividing this part here, the 10% only.
Oh, okay, got it. All right.
And that's when you add it to the 1. So I'm going to teach you how to use the tables later on. For now, I want you to go manual. Then 1.125 to the power 24. Yes, that is
when you divide 0.10 divided by 4, it gives 0.025, then 1, 0.025.
Okay, thank you for that. Thank you for that. It is 0.025. Okay, then that's when you power it to 24. Then what are you getting? What are you getting?
1.80872.
1 point. Is that what you are all getting? Is that what you're all getting?
Yes. Yes, it's the same one.
Okay. So if that's what you're getting, quickly want us to refer to an interest table, just quickly, so that I may be cute to bit the stone. Remember, what we are looking at is the future value. So we're using the future value interest factor. So you need to check, this is the present value and the future value. So the future value, this is the formula we're using. So we're using what percentage? What percentage were we using? Am I breaking?
No, you're clear.
Okay, so the interest rate we're using is what?
10%.
10%. All right. But since we compounded it quarterly, we're actually considering 2.5%. Then the period of time we're looking at what? 24. Okay. So under 24, you check that there's no 2.5 here, but you'd get something average between 2 and 3 if you're not using the table under 24. When you add this figure and that figure and divide by 2, the answer you get is the figure that we just found. I repeat, in the first instance, where we're looking at the annuity, the future value, present value factors. So if you want to calculate the future value for an interest rate of 8% after 5 years, so you check 8% under 5 years using this table. So what do you do when you go to this table? You check under 8%, then you go to 5. What are you getting? 1.4693. Are we together?
Mm.
Yeah, I just want to teach you briefly how to read the tables if you don't want to use the calculations. 8% under 5, 1.4693. So if you're finding the future value in here, you just call this the future value annuity, which is 1.469. So what you would have put in here is 1000 times 1.469. So when you apply 1000 times 1.469, you get the final figure of 1469. All right. I don't know whether I've lost anyone using the table. Can I repeat that again? As opposed to the formula that I'm talking about here, sometimes if you're given a present value of 1,000 and you're given a rate of say 5%, okay, let me put 6%, of say 6%, and your time is 3 years. So using the table, it usually takes a second for you to calculate such. If you're asked to find A, the future value of the 10,000 annually. So if you're using the table, it is quicker to use a table by using the formula. Future value is equal to the present value, the amount you have, multiplied times the future value factor. And our future value factor in this case is read as follows. You use 6% under 3 years. So we'll simply put as present value is 1,000. Then our future value factor, future value interest factor will be under 6%, and the years will be 3 years. So I just want to teach you how to use a table because it's given in the exam. When you go here, what was our percentage? 6%. And the years, the period in years, 3. So when you go to 6 and the period is 3, here you're going to put 1.1910. So if you're using the tables here, what you're going to have is 1,000. Then here we're going to have 1.1910. When we multiply that one, we're going to get 1,100. This would be the figure that would get using the table. So this is when we are dealing with it at an annual basis. But if you are being asked to find the future value and we're told semi-annually, can somebody tell me how does semi-annually affect the rate and the interest? Semi-annually means our M is 2. So our rate becomes what?
We'll have to divide the rate by 2 and multiply the time by 2.
Good. The rate is always divided by M and the time is always multiplied by M. So we're not going to check under 6%. We're going to check under what? 3%. Good. And our N, we're going to check under what? Under what?
6.
So 3 times 2, which is 6. So when we go into the table here, we check under 3% and our period of time is 6. So we're going to use 1.1941. So this is how we use the table. So we simply multiply 1,000 kwacha times 1.1941. Okay. So I just tried to make you familiar with the use of the table. So future value is very important when you're calculating the amount you're yet to get in future. Sometimes you'll be asked to calculate the amount that you need to have today. That is what we call the present value. So this is just one segment of calculating our time value analysis factor. Now, time value is very wide. I just want to ensure that you have been studying. I'll take this mini lecture as well as a class so that you may combine the two, what you've been reading, what has been happening. Now, if you're dealing with a series of future payments, it becomes what we call an annuity. When you're dealing with a series of payments, it ceases from being future value, it becomes annuity. So what have we discussed so far? We've discussed how to compound for a future value if you're dealing with an annual figure. If you're dealing with more than one period, we bring in an issue of compoundings, either in years, weeks, days, and the formula evolves a bit. So instead of using the annual formula, I've advised that the formula that we'll be using will be future value. Future value becomes